So this is the complex number sum, year 2005 LL. Question number 4. C1 and C2 be any two complex numbers. Construct the point representing complex number C1 plus C2. That one is very simple. Let C1 equals x1 plus iy1 and C2 equals x2 plus iy2 are represented by P1 and P2 respectively. In the Argand diagram, right? So you can take C1 equals x1 plus iy1, C2 equals x2 plus iy2 are represented by P1 and P2 respectively in the Argand diagram, right? Now how do you construct? When you construct these two complex numbers, you have to construct a parallelogram, right? O P1 C1, P2 C2, O X Y. Construct the parallelogram OP1 QP2, right? Construct the parallelogram OP1 QP2. Then C1 plus C2 is represented by Q. Okay. Then L is midpoint of Q. Let it's a dash equals x dash plus iy dash be the complex number represented by Q. X dash plus iy dash is a complex number represented by U. Then if you take x dash, then this coordinate is x dash y dash. Then L equals coordinates of L, you can write x dash by 2 plus y dash by 2 as L is midpoint of OQ. Similarly, L you can write x1 plus x2 by 2, y1 plus y2 by 2 as L is midpoint of P1 P2. Therefore, x dash by 2 equals x1 plus x2 by 2. Y dash by 2 equals y1 plus y2 by 2. So x dash equals x1 plus x2. Y dash equals y1 plus y2. Right? Therefore, it's a dash equals x1 plus x2 times I times y1 plus y2. That is x1 plus iy1 plus x2 plus iy2, that is c1 plus c2. So you can prove like this, construction of z1 plus z2. Now if you come to problem part of this sum, draw diagram illustrating the case when mod c1 plus c2 equals mod c1 plus mod c2. Now c1 plus c2 modulus c1 plus c2 modulus. How do you represent this case? C1 plus C2 modulus equals C1 modulus plus C2 modulus. In this case, so you have diagram like this. All three numbers are in same line, like this. Right? O, P1, P2. So this point Q, like this, all come to one side. Right? This is actually, what is this? What is this? This is OQ. This is OP1. What is this? This is OP2. Is it clear? Now if you compare with this diagram, if you look at with this diagram, what is, if OQ equals OP1 plus OP2, but OP2 equals P1Q, OP2 equals, so this equals, that is OP1 plus P1Q. Why is that? Why is that? Because OP2 equals P1, P1Q equals OP2. Opposite sides are equal in length. This length equal. Final, what is this? Of this triangle, OP1 plus P1Q equals OQ. That means sum of two angles, sum of two sides equal to third side of this triangle. Then what can you say about that? Then point P1 should come to this line OL. Same time, when P1 comes to this point, this line, P2 also come to this line, because this is parallelogram. Is it clear? When P1 comes to OQ, onto the OQ, then P2 also come to OQ. Then all three points should be on same line, like this. So you have to mark like this. So this is the case when mod C1 plus C2 equals C1 plus mod C1 plus mod C2. Right? Now in the case of, what is the general case? General case is, in generally, C1 plus C2 modulus less than equals mod C1 plus mod C2. Right? In general, what is in general doing? In general, one side is always less than sum of other two sides, no? In a triangle, if you take sum of two sides, always greater than or equals third side. length of the side, no? So, in general, you can say OQ less than equal OP1 plus P1Q from the triangle OP1Q, but OQ less than equals OP1 plus OP2. Why? Since P1Q equals OP2, these two sides are equal, parallel, since this is a parallelogram. Opposite sides are equal in length. What is this? This C1 was C2 modulus, this C1 modulus plus C2. So this is known as triangle inequality. Why we call this triangle inequality? Because you use a triangle when you prove this inequality, right? This is known as triangle inequality. Okay.
Sir, can you leave that last part for a minute? අන්තිම කෑල්ල චුට්ටක් පෙන්නන්න පුළුවන් sir? ඔව් sir, ඒකේ reasoning එක ලියන්න sir. Thank you sir.
Now you are given C1 equals minus 12 plus pi I. Mod C2 equals modulus of C2 equals 5. Find the greatest value of modulus of C1 plus C2. Right? How do you find that? Would you think it's difficult one? Now you are given this one, C1 equals minus 12 plus pi I. C2 is 5. What is this one? What is this? This one is variable out of these. C1 is constant complex number. C2 is not constant complex number.
Yes sir.
It's a variable complex number. How it's vary?
Because the imaginary part is not given.
Huh?
We can draw a whole circle, no sir, not a point.
It's only modulus is given.
Yes.
What is this circle actually? Circle
Yes,
of
sir.
radius 5 and center origin, this one.
Yes.
C2, that means C2 lies on a circle of radius 5 and center 0. This one is constant complex number, that one straight away you can mark it, right? One complex number is on this circle, right? On this circle. Other complex, this Z1 is exactly knowing that number, that is 5i plus 5i minus 12 plus 5i. Like this. So this is C1. This one minus 12. This one pi. Okay.
Yes,
C1 is a constant complex number. C2 is varying variable complex number on the circumference of this circle. Right? What is the greatest value of C1 plus C2? C1 plus C2, what is the maximum of C1 plus C2? What is the greatest? Possible equals, that is C1 plus C2, greatest value, right? And when they are collinear, two complex numbers are collinear, you get the greatest value. That means greatest value you get two lines are collinear. Then always this value is less than equal this, no? When is greatest, sum of these two. Right? What is the mod C1? Mod C1? That is 12 squared plus 5 squared whole thing square root. That is 13. Right? This length is 13. That plus this length. Then C1 plus C2 greatest equals 13 plus 5. That is 18. Okay. In this case, there are two corresponding positions. This point P1 and P2. So let's say P and Q. PQ. P and Q are the corresponding positions that C2 can take. Right? P and Q, these 2 points, both points can available. For both points, this point C1 plus C2 is greatest. Right? Greatest. If C1 plus C2 has its greatest value and also 5 by 2 greater than C2, arc C2 less than 5, express C2 in the form of P plus I chi. If greatest, there are two positions. Now they are asking if the argument is greater than pi by 2, less than 5. You can this point. If arc C2 greater than pi by 2, less than 5, then it says 2 equals but this angle theta 5 minus pi cos pi by pi theta plus pi sin theta. What is theta? Cos theta equals (12/13). Sin theta equals pi/13. So if you substitute minus pi times into 12/13 plus pi times pi/13. So if you take pi out, pi/13 out, minus 12 plus pi. So C2 equals then C2 equals pi/13 times minus 12 plus pi I. C2. Right? මොකද මෙතන තියෙන දේ මෙතන ඉක්විලන්ට් මේ සිමිලර් ට්‍රයැන්ගල්ස් දෙකක් තියෙනවා. ඉතින් මේ θ නොගෙන කරන්නත් පුළුවන්. මේ සිමිලර් ට්‍රයැන්ගල්ස් දෙක කම්පෙයාර් කරලා මේ කෝඩිනේට්ස් වලින් මෙතන කෝඩිනේට්ස් හොයා ගන්න පුළුවන්. එතකොට C2 ගන්න පුළුවන් කෙලින්ම. right? මම කරපු විදියෙන් බලන්න අවශ්‍ය නැහැ. කැල්කියුලේට් කරලා ගන්න පුළුවන් මේ ලක්ෂය. මොකද මෙතනදී අපිට ග්‍රේටස්ට් වෙන පොයින්ට් දැන් මේ PQ කියලා දෙකක් තියෙනවා. එතකොට මේ අවශ්‍යතාවය දුන්නාන් පස්සේ arg is 2 කියන එක greater than pi by 2 less than pi. එතකොට මේ පොයින්ට් P තමයි ගන්න පුළුවන්. તો P වල කණ්ඩාංක මේ ලක්ෂය භාවිතා කළා මේ ලක්ෂයේ කණ්ඩාංක හරියටම දන්නවනේ. -12 5. ඉතින් සිමිලර් ට්‍රයැන්ගල්ස් දෙක යොදාගෙන මෙතනයි අපිට P හොයා ගන්න පුළුවන්. right? හරි ලේසි ඒක. මම මෙතන -5 cos theta plus pi sin theta I කියලා ගත්තා. එහෙම අරගෙන තමයි මම ගත්තේ. නමුත් ඒ විදිහටම එන්න එතන ඕනනම් compare කරන්න පුළුවන් මේ sides of these two triangles දෙක. එහෙම ගන්න පුළුවන්. right? Now next part, now you are given 4 points A, B, C and D, representing complex numbers C1, C2, C3, C4. Now you have to show if AB is perpendicular to CD, then C1 minus C2 over C3 minus C4 is purely imaginary. How do you show that? These three are purely imaginary. Right? Now you are given you had arc. You just consider arc C1 minus C2 over C3 minus C4. This is what you are given, no? No. You just consider this one. You just consider this one. Consider this, but we have to show C1 minus C2 over C3 minus C4 is purely imaginary. We have to show this purely imaginary. Right? Purely imaginary. But you consider this one, just put in argument. You consider argument of this one. This one equals arc C1 minus C2 minus arc C3 minus C4. What is arc C1 minus C2? C1 minus C2 is, this is the angle this is angle that C1 minus C2, that is BA makes with x-axis, right? So angle, so this is the angle, so this one is the angle that BA makes with the x-axis, positive x-axis, right? What is this? This is the angle that මොන angle එකද කියන්න බලන්න මේක C3 minus C4. We practice very well. C3 minus C4. When you say C3 minus C4, the pen moves to this direction, right? You consider opposite
the
direction.
other sense.
That is DC make with the positive x-axis, the angle that DC makes with the positive x-axis. Right? What is this difference? This difference. But if they are perpendicular, BA and CD are perpendicular, you can say this equals pi by 2, plus or minus pi by 2. Why it is plus or minus pi by 2? Because since BA is perpendicular to DC, right? Both of the lines make angles with same axis OX, right? BA makes, you don't look at this diagram. Without looking diagram, lines දෙකක් තියෙනවා දුවේ. එකම axis එකක් සමග සාධන කෝණ දෙක තියෙනවා. ඒ දෙකේ difference එකකින් එන්නේ මොකක්ද? ඒ lines දෙක අතර angle එක. right? පැහැදිලි නැද්ද?
පැහැදිලි sir.
පැහැදිලි.
ඔව් sir.
right? දැන් line එකක් තියෙනවා. මෙහෙම axis එකක් තියෙනවා. මේ line එකත් එක angle එකක් හදනවා. අනිත් line එක තව angle එකක් හදනවා බීටා කියලා. දැන් බීටා minus alpha වලින් දෙන්නේ මොකද්ද? මේ lines දෙක අතර angle එකනේ. ඒ වගේ නේද? So let's plus or minus pi by 2. අපි දන්නේ which one is bigger. Right? If argument is plus or minus pi by 2, then you can say therefore C1 minus C2 over C3 minus C4 is එක්ක මේක positive y axis එක තියෙන මත තියෙනවනේ නැත්නම් negative y axis එක මත තියෙනවා. negative y axis එක මත තිබ්බොත් තමයි minus pi by 2. positive y axis එක මත තිබ්බොත් complex number එක plus pi by 2. argument එක. හැබැයි මේ argument එක මේකේ argument එක අපිට argument එක නේ මේ complex number එක මොකද කියන්නේ? එහෙනම් purely imaginary. අපිට මේක ප්‍රකාශ කරන්න පුළුවන් ki ආකාරයට. this complex number. ඇයි y axis එක මත මේක තියෙන නිසා. therefore C1 minus C2 or C3 minus C4 is purely imaginary. පැහැදිලිද? Is it clear?
Yes sir. Understood now sir.
That's all, eh?